how do researchers use satellite imagery to monitor climate change in polar areas. If you are curious about how scientists keep an eye on the rapidly changing polar regions, you are in the right place. Let us explore how satellite imagery plays a vital role in monitoring climate change in these icy areas. Satellites are like orbiting observers, constantly watching over the Earth. In the polar regions, they use various types of sensors to gather data. For instance, polar orbiting satellites travel from one pole to the other, capturing images of every part of the Earth's surface several times a day. This allows scientists to track daily weather changes, seasonal variations, and yearly trends, all of which are crucial for climate research. These satellites are equipped with advanced instruments that measure different aspects of the environment. Some sensors detect atmospheric and surface temperatures, while others monitor oceanic conditions, vegetation, cloud cover, and water vapor. They even use radar to assess surface features like snow cover and soil moisture. This diverse range of tools helps scientists gather comprehensive data on multiple climate indicators. One of the key ways satellites monitor the polar regions is by measuring ice sheet thickness and glacier movement. Satellites like the European Space Agency's Cryo and NASA's ICE Sat-2 use laser altimetry to determine changes in the elevations of glaciers and ice sheets. This data shows how quickly ice is being lost in regions like Greenland and Antarctica, which is vital for understanding the impact on rising sea levels. Sea ice extent is another critical variable. Satellites observe changes in sea ice, which is essential for understanding polar ecosystems and global climate patterns. As sea ice melts, it affects the Earth's surface temperature because the darker ocean water absorbs more heat. This process further accelerates global warming. Satellites also track the movement and retreat of mountain glaciers. By monitoring these glaciers over time, scientists can understand the regional impacts of climate change and predict future water resource availability. Additionally, satellites monitor the thawing of permafrost, a layer of frozen soil in polar and subpolar regions, which releases methane as it melts, further contributing to global warming. Sea level changes are closely monitored using radar altimetry. The JASON series of satellites, for example, measures global sea level rise with high precision, which is vital for planning and preparing coastal communities for potential flooding and erosion. Temperature monitoring is another crucial aspect. Satellites use advanced infrared sensors to measure the heat radiating from the Earth's surface and atmosphere, both day and night. This provides a complete picture of temperature patterns across the globe, especially in remote regions where traditional temperature measurements are difficult to obtain. In the Arctic, satellites like ESA Cryosat and Copernicus Sentinel-3 measure sea ice thickness and volume. These measurements have revealed significant declines in Arctic sea ice, particularly during the summer months. This data helps scientists understand the long-term trends and variations in the Arctic, contributing to a better understanding of the region's response to global warming. By combining data from multiple satellites and integrating it into models, scientists can predict future climate scenarios and help governments and communities prepare for the impacts of climate change. This makes satellite imagery an essential tool in the ongoing effort to monitor and understand climate change in the polar regions.